that in your notes, because you have your notebook open. And then you had to have written compare decimals as the title of today's lesson. The date never hurts either, because that way if you need to look back, you remember what day it was. So today, raise your hand if you remember doing the lesson where we took a bunch of really big numbers that were up into the millions place, and we had to say which one was greater, and then sometimes we had to put them in order like a 1, 2, 3, and 4. Raise your hand if you remember doing that. It was just last week, so hopefully you didn't forget. Okay, good. So we're going to do the same thing today, except we are using decimals. Okay, so today's lesson is we are comparing different decimals. So we're going to compare them and see which one is bigger. And I'm going to give you a really easy way to make sure we do that. Okay, but the bottom line of this lesson is the same thing as what we did last week. We're starting in the farthest left, and we're going to start comparing each place value with the other one and make sure whichever one is bigger is going to be the bigger number. Okay, as soon as you get to a bigger place value, it's going to be a bigger number. That's the basics of what we're doing today. So we are using place value because we have to make sure that we're comparing the ones place with the ones place, the tenths with the tenths, the hundredths with the hundredths. We have to make sure that we're comparing the right place value together. We're going to skip this one today because we are running short on our time. It took us a long time to get set up today. So we're going to go right into our notes. So we just skipped the problem of the day. You will use your whiteboard in a little bit, but we're going to get into starting our notes. Make sure we get all those copied. So we're on chapter 1, lesson 7. The question asks, what are some different strategies that we use to compare decimals? So the number one strategy that I want to share with you is something that's going to really help you, because when you have a couple of different decimals that you're trying to compare, it's super important that your decimals are lined up with each other. Okay? So the number one thing that people do wrong is they start to compare the decimals without first lining them up. So that means you're comparing the wrong place values together. So the way that you can fix that is by starting off with your decimal points. So unlike me, you guys have lines on your paper. So you can use, use two lines, one on top of the other, to put those decimal points. And then I'm going to give you some examples and we're going to fill them in. And in a minute I'll tell you why it matters that you're comparing the right place values together. So my first question is 3/10 and 8/10, and we're going to compare using greater than, less than, or equal to. If I have my two decimal points that I drew right here, and then I start to fill in around, that's all I do. And then I can start on the left-hand side over here, comparing, and those are both zeros. Then I have a 3 and an 8. So which one of these numbers is bigger? Which one of these numbers is bigger? 8. So 8/10 is bigger because 8 is bigger than 3. So that's the way, that's the way that my sign would go. Now, the reason why, I'm going to show you another example showing you why the reason why it matters, because you may get problems like this one. So here's another example. If I give you 9/100 and 2/10. So if you chose to not follow directions and you chose to not write the two dots, like the two decimal points like this, like I showed you, and you just started to compare, which number might you think is bigger? Because I see a 9 there, don't you? What number might you think is bigger?
The 9.
The one with the 9 in it, right? Because it's 9/100. And so if somebody's not really using place value to compare, they may just look at the numbers that are the non-zero numbers and automatically say, oh, the 9's bigger. But that's not the case, because watch. If I use my two decimal points here, and then I fill in my number around my decimal points, look what happens. Which number is actually bigger? Hazma, which number is actually bigger? So how would you read 0.2 like a decimal? 2/10. So 2/10 is actually the bigger number. So see why it's important to put those decimals one on top of the other? So sometimes people think of it like this. Right? Because see how the decimals are not lined up on that one? So they may automatically think that that one's bigger. So we're going to say that is what you don't want to do. So put that in your notes because it's going to help you to remember. So see how, like, because the reason why is because we're used to working with numbers that go out like on the other side of the decimal point. We're used to using the numbers that go to the millions or the thousands, and they don't have a decimal after it. And so that's why we usually line up along the right hand side, right? That's called right justify. So everything is kind of lined up with each other automatically. Like the numbers 174 and 23. See, if I were going to compare those numbers, I would line them up all the way to the right. See? But when you're working with decimals, it's important that you line up the decimal points, because you have, just like we said at the beginning of this lesson, you have to compare each place value together. So if I compared this way, I'm comparing the ones place with nothing, and then I'm comparing the tenths place with the ones place. And you can't do that. You have to make sure you're comparing the tenths with the tenths, the hundredths with the hundredths, the ones with the ones, which is why if you just take a second to make these two dots here for as your decimal points, and then you fill the numbers in around, you never will make that mistake. Okay, because it's really easy just to look at it and go, oh, that one's a 9, that one's a 2, and then you accidentally put your sign going the wrong direction. Nolan.
I'll tell you after.
Okay. Okay. All right, let's do another example. One more.
Okay.
And then we'll do some on your whiteboard and some other things. So this is 1 7/10 and 1 2/10. So this is in your notes. So start just like I showed you with the two decimal points, one on top of the other. Then you're going to fill those numbers in around the decimal point. This skill comes in handy when we start to add decimals, which we do later, and we subtract decimals, because we do the same thing. We place our decimal points first, just so we have them all in the right place, because you have to make sure that you're keeping with your place value. So if I start with my ones and compare, I have two ones there, which means they're even so far. And then in my tenths place, I have a 7 and a 2. So which one of those numbers is bigger? Make sure you know how to read it before you tell me. How would you read it, Nayeli?
1.7 and 1.2, and the 7 is larger than the 2.
The 7 is larger than the 2, but instead of saying point, we're going to say and, right? We're going to say 1 and 7, the place value, which is tenths. So 1 7/10 and 1 2/10 is what we're comparing. And 1 7/10 is going to be larger, so it should go that way. Any questions so far? This one's pretty okay, I hope. Because we did comparing before. It's pretty close to what we did when we compared the other day. So look on your whiteboard. Gonna let you do this example. Your whiteboard should already be in front of you. It's just a matter of looking over at it. So make sure you use the strategy that I showed you of the two decimal points, one on top of the other. Write the numbers in. This time they're dollar amounts. You can sharpen. Thank you for waiting. We have to think. Sometimes it's easy for us to do each place value, like going through comparing. But sometimes if you just stop for a second and think, what are they actually asking me? You can get the answer. At least you can get an idea of what you think the answer is going to be, and then you can check it by doing this method that I showed you. So if I'm looking at two amounts, one is $84.54 from selling clothes, and the other one is $71.88 selling toys, I'm thinking, which one do you think might be worth more? Like, just think of the whole numbers without thinking of the decimal points. What whole number is worth more?
I would say that Jason's school made the selling the clothes
Yes.
earned more money than selling toys.
Right, because it's $84. And $84 is always going to be more than $71, right? And so if you've ever gone shopping, then you would know that $84 is going to be more than $71. It's just a bigger amount. So for this one, we didn't have a whole bunch of zeros and other numbers in there that would detract us from getting the right answer. So, but you may think, I think it's $84, but I'm going to check my answer just to be sure, because it's always a good idea to double check your answer. So if you're writing in the number around the decimal point and then you start to compare, you can see that $84 is definitely more than 71, because the very first digit is in the tens place, and when I'm comparing the tens place, an 8 is bigger than a 7. Okay? Yes? Nope. Yeah, it's fine. No, it's fine. Okay, tell me in a minute. Okay, tell me in a minute. I'm going to clear this one. I'm going to go on to the next screen. I want you to do one more on your whiteboard. Here's a model. Okay, I'm going to help you with this one a little bit. Then I'm going to ask you to do some of it on your own. So, how many squares are in this box? How many squares do you see? Without actually trying to count them. Amelia. Oh, you counted all of those. Okay, how many are there total? How many of them are there total?
100.
This is a 100 box, right? And so she already told me there was 42 because she went 10, 20, 30, 40, and then you have 1, 2 here. So 42. So this says to generate 2 decimals that are greater than the model and 2 decimals that would be less than the model. So here's the fraction form. Here would be the decimal form of that number, right, of that model. So what you have to do on your board, and there's going to be several different answers, a lot of different answers, make 2 decimals that are more than 42 hundredths and 2 decimals that are less than 42 hundredths. Okay, think of 2 that are bigger, 2 that are smaller. Okay, I'm going to erase what I've written here. We have some confused people, so let's look at, here's your amount, right, 42 hundredths. Now they would like you to, using the same model here, which means you can't go over hundredths because there's only 100 squares here. I'm going to think of one number that's bigger than 42 hundredths. I'm going to put 67 hundredths because a 6 is bigger than a 4, which is going to make that number bigger. And then a number that's smaller, I'm going to put 28 hundredths because a 2 is smaller than a 4. So really, aren't there like 41 different answers for the smaller than? Because you could put 1 over 100, 2 over 100, 3 over 100, 4 over 100, all the way up to 41 over 100 and make it, and it would be smaller than 42 hundredths. Then you have a whole bunch that could be bigger, like 58 that could be bigger, because you could say 43 hundredths, 44 hundredths, 45 hundredths, 46 hundredths, all the way up to 99 hundredths. Okay, and to make it a bigger number. So that's why I was saying there's lots of different answers. On this, yes, that's good. On this one, they were trying to just see, the reason why this question is asked of you is because they're trying to see if you can tell, just without having 2 numbers to actually compare, if you can come up with 2 numbers that are bigger than a number, or 2 numbers that are smaller than a number. So anything that's smaller than 42 is going to be smaller than 42 hundredths. Any number that's bigger than 42 is going to be bigger than 42 hundredths, as long as the denominator is still 100. As long as the denominator doesn't change. Okay, give me a thumbs up if you understand that now, even if you didn't understand it when you were trying to solve it. Okay, good. Awesome. Okay, look over at your math page. Hold on. Without making a bunch of noise, keep your whiteboard there, keep your notes there. Just look over at that math page. 3, 2, 1, 0. Remember, I want to make sure you have enough time to do this independent practice. Just waiting for everybody to be ready.
Everybody be quiet.
Okay, so example number 1 says that Luis downloaded 2 songs onto his MP3 player. Which song is longer? So you have 3/6 and 3/8. Now on this example, they're actually showing you one way is to use a number line, which we didn't do as part of our practice today, but a number line is a good way to find out which number is bigger. 3 6/10, you can see where it lands on the number line, and 3 8/10. And obviously the further right you go on the number line, the bigger the numbers get. So looks like 3 8/10 is going to be bigger. The other way, we're going to write, I want you to write this on the side over there, is this already another way, huh? Okay, never mind. See, I have different slides as you. Let me go to my next slide. There we go. Another way is to line up those decimal points and write in the numbers around it, and then start comparing based on their place value. So since 8 is larger than 6, and those are both numbers that are in the tenths place, that means that 3/8 is bigger than 3/10. Sorry, 3/8 is 3 and 8/10 is bigger than 3 and 6/10. That's what I meant to say. So that would be song number 2 is longer. Yes.
And there's still one more question. It says the ones digits.
The ones digit. Okay, so by number 1, the ones digit are the same. So the 3 and the 3 are the same is what they're trying to show you. Okay, look at example number 2. Please make sure you're on example number 2 with us and nowhere else on your paper. This part's important, so make sure you're this is why I don't want you to try to move on. I know some people are saying, like, I already know how to do this, so I'm going to start going. But I need to share with you this part because we actually use this term a lot, and it comes up first in this lesson. So this is the next page. So go to the back of that page. It says, decimals have the same that have the same value are equivalent decimals. So here's what they're showing you. 8/10, we kind of talked about this the other day, and 80/100, those are equivalent. So this is a new word that now that you have everything with you, we write it in our notes in a couple of days, but I just wanted to introduce this word to you because they actually use it here. It's this word. The word is annex. So when you annex a 0, what that means is sometimes when you're comparing numbers, do you see how this number goes all the way to the hundredths place and this number only goes to the tenth? So you kind of have this blank spot right there. So when you annex a 0, that means that you place a 0 in any empty spots so that you can more easily compare all the way across. So you're not comparing like a 2 with a blank. Instead, you have a 2 with a 0. So the term for that is called annexing a 0. So we actually use that term a lot when we talk about decimals. So I want to introduce it to you today, and then we will put it in our notes on a different lesson, but I want to make sure you know what it means. So it does not change the value of the number. That's what's important to know. Whenever you add a 0 at the very end of a number of a decimal, it doesn't change the value of that decimal. So 80/100 and 8/10, see this, they are equal to each other. Okay, there wasn't any work for you to do there, that was just for you to see. So if you look at the question, example number 2, this is where they're trying to get you to annex the 0, because if I lined up my decimal points and I wrote in the numbers, see I have this blank spot in the hundredths place. So I can annex a 0 into that blank space so that I can more easily compare the numbers. I didn't change the value of the number by adding that 0. So now I can compare 8s with 8s, 6s with 6, and 9 with 0. So if I add my 0 here, that means that 8 and 69/100 is larger than 8 and 6/10, or 8 and 60/100, because those are equal to the same amount. So we're going to put this sign right here. So when you annex a 0, basically what you're trying to do is even it out so that both numbers have the same number of digits in their number. Yes?
But it wouldn't exactly be the same value like if you were reading it, because if you were to annex a 0, the place value would become, I don't know what to
Okay,
say,
so let me,
lower or higher.
I see what you're saying. So if I have this number and I ask you to read it, 8 and 60/100,
It's different than 8 and 6/10.
you're right,
which
but
it started
But here's why. If this were your answer to a question, like let's say we got into, right now all we're doing is comparing. But once we get into adding decimals or multiplying decimals or dividing decimals, if this is your final answer to one of those types of questions, you would leave that 0 off. That's a 0 that doesn't matter. So then your actual answer would be 8 and 6/10. So I see what you mean is that when you read it, you may read it as a different way, but really me saying 8 and 6/10 and you saying 8 and 60/100, we are talking about the same value. So, because if you think of the picture, if you have 6/10, it's 6 of the long pieces, right? If you have 60/100, it's 60 of the small little squares, and 10 of those make a long. So, yeah, so we are actually saying the same things, it just sounds different. It's like if I have 100 pennies and you have 10 dimes, we have the same amount, but you're using dimes and I'm using pennies. So That's what I'm saying. So you would actually, it's the same value, just sounds different. But when we're doing later on, we'll talk about how you take that number off. Okay? All right, for the next few minutes, like 2 or 3 or 4 minutes, I want you to work on the guided practice with the people who you sit by, just like yesterday. When you're finished with the guided practice and you've checked those answers, so I don't want you to move on until you've made sure you're doing it right, then you can go on to the independent practice by yourself. Okay? So in a couple of minutes, I'm going to start your timer.